Well, hello there, 5th grade math students. We've come to chapter 13.4, which is triangle inequalities. We're going to work to understand that the sum of the length of any two sides of a triangle is greater than the length of the third side. Just that one concept, and we're going to work hard on it. So let's begin. We're going to work together to show that the sum of the lengths of two sides of a triangle is greater than the length of the third side. This triangle, ABC, has three side lengths. Side AB is 7 centimeters, side BC is 5 centimeters, and side AC is 4 centimeters in length. Let's refer to the chart to help us prove our rule. Side AC plus side BC is 4 plus 5. That equals 9 centimeters. That is greater than the length of side AB, which is 7 centimeters. 9 is greater than 7. Remember, this is called an inequality statement. 9 is greater than 7. So, AC plus BC is greater than AB. So far, our rule is true. The sum of two sides is greater than the length of the other side. Let's compare two different lines. AC plus AB. 4 centimeters plus 7 centimeters equals 11 centimeters, which is definitely greater than 5 centimeters, the length of side BC. 11 is greater than 5, so AC plus AB is greater than BC. Our rule is holding up so far. Now let's take a look at our last example. Line AB plus line BC. 7 centimeters plus 5 centimeters equals 12 centimeters, which is definitely larger than 4 centimeters. 12 is greater than 4, so AB plus BC is greater than AC. Our rule has worked for all three cases. Let's practice this idea with another triangle. PQR is a triangle in which PQ equals 8 centimeters, QR equals 10 centimeters, and PR equals 6 centimeters. I'll work through number 1 with you, and then I'd like you to try number 2 and 3 on your own. Find PQ plus QR, then compare the sum with PR. Okay, line PQ is 8 centimeters in length. Line QR is 10 centimeters in length, for a total of 18 centimeters. Line PR is 6 centimeters in length, therefore PQ plus QR is greater than PR. Now that you've seen me work that example, try number 2 and 3 on your own. Press pause while you work, and move on when you are ready. Our next idea is that it is possible to be given three lengths that may not form a triangle. Let's begin with three lengths and determine if we can use those lengths to create a triangle. Our lengths are 5 centimeters, 6 centimeters, and 7 centimeters. We'll assess if this works by testing if the sum of the lengths of two sides is greater than the length of the third side each time. Let's begin with 5 plus 6 equaling 11. 11 is greater than 7, so far we're good. Now let's try 5 plus 7. That equals 12. 12 is greater than 6, our remaining side length, so two sides pass the test. Let's try the last side. 6 plus 7 equals 13. 13 is greater than 5. Therefore, it is possible to form a triangle from these three lengths. And here is that triangle. Let's try another example like this. Our three side lengths in example B are 2 inches, 4 inches, and 1 inch. Let's test it out. 2 inches plus 1 inch equals 3 inches. And 3, is less than 4. That's not good. Let's try another one. 2 inches plus 4 inches equals 6 inches. Well, this one passes. 6 is greater than 1. Let's try the last. 4 plus 1 equals 5. And 5 is greater than 2, so that side passes as well. However, we cannot form a triangle. If we draw the 4-inch side first, we can see that we cannot make the other two sides meet. Look. The resulting figure would look like this. Please evaluate these two problems on your own. Given these three lengths, can a triangle be formed? Use the same process that we used on the two previous examples to compare the sum of the side lengths of two sides to the third side. If all three sums are greater than the remaining side, you can make a triangle. However, if any of those result in a sum that is less than the length of the remaining side, you cannot form a triangle. Test it out, and when you are finished, move on to the final concept of this chapter. For the last concept in chapter 13.4, we're going to find the possible length of a side of a triangle given the length of the other two sides. We'll begin with this information. The sides of triangle ABC are in whole centimeters. AB is equal to 11 centimeters, BC is equal to 14, and AC is greater than 20 centimeters. So we don't know its exact length, we just know it's longer than 20 centimeters. Find the possible lengths of AC in whole centimeters. Okay, so let's use that rule that we know, that the sum of the lengths of two sides must be greater than the length of the third side. We'll begin by adding AB plus BC, 11 plus 14, which gives us 25. Therefore, we know that line AC must be less than 25 centimeters, correct? Because if it's 25 centimeters or more, it will be too large to have a triangle be formed. Let's reiterate that. AC must be greater than 20 and less than 25. So the possible lengths of line AC are 21, 22, 23, and 24 centimeters. All right, folks, here's your last practice problem for this lesson. XYZ is a triangle in which line XY equals 11 inches and line XZ equals 19 inches. The length of YZ is in whole inches and is greater than 26 inches long. Find the possible lengths of YZ. Follow the exact same technique we just used in our practice problem. I will see you tomorrow to do more, and we will work more with triangle inequalities. See you then.